Hey everyone, so today we will be looking at Foundry framework and how to install it, and I will be explaining some feature of it, right? So let's get started with what a Foundry framework is. So Foundry is a framework which is used to test Ethereum or EVM based smart contracts written in Solidity. So currently it has four tools under it, that is Forge, Cast, Anvil and Chisel. So let's get started with installing it. So to install it, we can simply we have some multiple options, like we can use Foundry up. We also can build it from source using Rust or Cargo, and then we have some other option to install it with Docker. We will be using the most easiest one, that is using Foundry up. We just need to fire up our terminal and paste this command and hit enter, and yeah, it will just download it, and then we need to run this source command, and finally we need to run Foundry up. It will install all the four things of the Foundry. Yeah, it's like it hardly took a minute, right? So we have Forge, Cast, Anvil, and Chisel, all of them installed. Now let's look at what these all are and like why it's beneficial. So we have Forge. Forge is similar to Hard Hat or Browning, in which we can test, build, and deploy our smart contracts. And then we have Cast. Cast is a command line tool for performing an Ethereum RPC call. We can make smart contract calls, we can send transaction, and we can retrieve any type of data such as private data from blockchain. So we can see some example how we can decode some data and all. And then we have Anvil. Anvil is a local testnet node with Foundry, so it's similar to Ginache. So we can spin up our own local node and we can test on that node. It's very useful when we are testing smart contracts and we need to test it very fast, so we can use it. And then finally we have Chisel. It's a relatively new one, and it's an advanced Solidity REPL, so it can be useful to quickly test the behavior of Solidity snippets on local or fork networks. So it's very useful, and for more detail we can just refer to this reference, and we will get all the commands and everything how we need to run all these things. So let's move on to Forge. So why do we use Forge instead of other frameworks like Hardhat or Brownie? So the first thing is that it's very fast and flexible as compared to other framework. We can see that the DApp tools which takes to compile Soulmate, it takes around 6 minutes and 34 seconds. The same thing Foundry does in 2.8 seconds. So it's around 140x speed. It's around 140x faster. So apart from speed, it's very easy to set up. We just saw that it hardly took us a minute to install it, and we don't need any package manager or anything fancy to install it. We have some other features like fast first testing and some RPC forking. We can easily fork it, and we have some debug logging. We can log our data or the test easily using Forge. So for this video we will be writing ERC20 token, and we will be testing some of its function using Forge. So let's get started with it. So first command we can run is Forge help, and we will get all the options which we can use using Forge. So we can see we can init a new project using this init command. So we can simply write Forge. Okay, first of all let me go back to my Quill Academy directory. So let's init a project, Quill token. It will take a bit of time, maybe. Yeah, it's done. So let's move on to Quill token, and Let's spin up our VS Code very fast. So the first thing we have is lib. It contains the libraries. We can install some external libraries such as OpenZeppelin or Soulmate, and it will be in this directory. And then we have script. So in this script folder, it will contain all the script for deploying the smart contracts and all the deployment scripts. In the source there will be the actual smart contracts, and in the test there will be some test file for testing the smart contract. Also we have some other configurations such as git ignore, git module, and foundry.toml file. So foundry.toml file is a configuration file for Foundry. It consists of many configurations which we can use to test Foundry more efficiently. We can find more detail about this configuration at this URL. So now we can begin with testing our ERC20 tokens. So first we need to create one. To create one, let's import OpenZeppelin library. We can simply write import ERC20 from OpenZeppelin contract. It's showing this error because we haven't installed the dependency yet. We will install it now. So to install the dependency for OpenZeppelin contract, head up to the terminal and simply write forge install OpenZeppelin / OpenZeppelin - contract, and we can add the flag no commit. We'll install OpenZeppelin very quick. So now that OpenZeppelin is installed, let's try to build this contract first. Okay, so let me remove this and rename this as Quill token, and also from here we can simply remove it, and let's remove them all too, and let's try to do force build to see if it's building or not. So we can see that we haven't configured the remapping yet, so we can run the command forge remappings, and we can add it to remappings.txt to configure it more easily. Yeah, we have the remapping.txt so folder, so we can simply write contract over here and save it, and I think it will build successfully. So we can see that it's compiled, and yeah, it's successfully run. So now that it's successfully run, let us create an ERC20 token. Let us inherit the 20. Yeah, the next thing we need to do is add a constructor, and we will pass into address, that is we will pass into data, that is string and symbol. So let's add it, and then we will be supplying the same data to ERC20 to create a token out of it. So I think we are pretty much done with the token itself, and let's import the file over here. So we can change the contract name from counter to Quill token, and also we can change the contract test to Quill token dot t dot sol, and change this to Quill token. I think it should work. There is a mistake over here. Let me check what's the mistake. Yeah, we didn't add the source over here. Now I think it will work. Yeah, it's completely working. We were successful in building it. So now we will be writing some test for our ERC20 token. So we will be adding some more function for it. The first thing we will be adding is mint function to mint our token to any address. So here is the mint function, which is calling the internal mint of the ERC20 token, and then we will be adding a burn function. So it will be helpful while testing for the contract. So our contract is pretty much ready, so let's build it once more to check. Yeah, it's working perfectly fine. Now we will be writing our contract test. Let's rename this as token test. Okay, so in Foundry unit testing, so we have two things. That is Foundry setup, where we will be setting up all our contract for testing, and then we have test. So each function test, we will be testing each and every function individually. So let us first create an instance of quill token over here, so that we will be deploying our instance for testing. And then we can create a Foundry setup. We can simply add function setup to create a setup function for this, and then we can simply add public keyword. And yeah, so for this testing, we will be deploying this quill token. So to deploy it, we can simply write the quill token new, and we can simply paste this, and in this parenthesis, what we will be writing is the constructor parameter, that is our name and symbol. So we can simply write quill token as our token name, and for our symbol we will be writing qt. So pretty much our setup is done. So let's write our first function for testing the name and symbol of the contract. So we will be write test name and and symbol. So it will not take anything, and let's make it external. So basically in this function we will be testing if our token name is quill token and its symbol is qt or not. To do that, we can simply add an assert equal, and we can add the quill token which we have assigned over here. Okay, so there is a space, yeah, that's fine. And we will be asserting for quill token dot name, which is an ERC20 function. So let's check the name first. So we can write forge test to test this. So we can see that it's passed. So the next thing we will be doing is testing for our symbol, if it's actually assigned our symbol or not. For that, we can add qt over here and quill token dot symbol, which will return the symbol for our ERC20 token. And let's run the test once again, and we can see that it's successfully passing. So we have tested two very basic thing for ERC20 token. Next we will be testing is the main function. To test main function, we can simply write test mint, and let's make it public. So to test mint, let's add a address for the user. So we have added EOA Alice, and let's add one more EOA, that is Bob. So first thing what we will be doing is we will be minting Alice 1 ERC20 token. So we can see that we are minting Alice 1 ERC20, we are minting Alice 10 ERC20 token, and then we will be checking if Alice actually has 10 ERC20 or not. So to do that, we can simply write assert eq, and then we can simply add the token balance of Alice, and in the next parameter we can add 10 e to the power 10 is 10 e to the power 18. And let's run the test once again to see if is successful or not. So we can see that test mint also passed successfully. The next thing we will be testing is we will be testing burn function. So let's write again a new function, test burn public. To burn anything like any token, first we need to mint it, so we will be copy pasting the same thing. Yeah, we have minted Alice 10 token, and let's try to burn, let's try to burn 5 token from Alice. And let's assert if our burn was successful or not. Assert eq will token dot balance of Alice should be equal to 5 e to the power 18, because out of 10 token we have burned 5, so 5 should be left in the Alice UA or Alice account. So we can see that we have successfully tested it and it passed. So these 3 were very basic tests. Now we will be moving with transfer test. So for testing in transfer, you can simply write transfer test, and let's make it public again. So for transferring any asset, first we need to mint Alice token and then let's transfer it. So we will be using vm.start prank, which is a cheat code for Foundry. So what start prank is, it will assign message.sender to Alice for all the external calls until we call vm.stop prank. So let's transfer in between. So what we can do is we can simply call quill token dot transfer to Bob, and we can see that we have minted Alice 10 token and we have transferred 2 to Bob, right? So let's assert for Alice and Bob. So what we can do is just copy paste the same thing. So according to our code, the balance of Alice should be 8 token and the balance of Bob should be 2 token, right? So we have pretty much done. So let's try the forge test again, and we are seeing some issue. Let me check what's the problem. Okay, so the problem is over here. So we haven't renamed it to Bob. So let's do it again, and yeah, we passed the test. So this was a transfer test. It was very easy. Okay, so let's try to send this 2 token back to Alice being a Bob. So we can start prank as in Bob, and we can simply call the transfer function to Alice, and we can simply call this stop prank over here. So according to this, the balance of, according to now, the balance of Alice should be equal to 10 and Bob should be equal to 0. So let's test this function once more, and we can see that it passed successfully. Now what we can do is we can write dash vvv for for verbose output. We can write up to 4, so it will give each and every call within the function itself, and we can check it with more details. So this is it for this video. We will soon be covering other tools for Foundry such as Cast, Anvil, and we will be also doing some fuzz testing. And keep following Quill Academy for more such videos.